Habituation, the simplest and most ancient form of learning, is a universal phenomenon observed across all living organisms. It involves a decrease in response to repetitive stimuli and is crucial for organisms to adapt to their environments efficiently. However, the disruptive influence of entropic waste, especially in the form of radio frequency radiation, or RFR, can interfere with this fundamental learning process. Entropic waste refers to the disruptive and disorderly impact of RFR on biological systems and natural environments. It encompasses the non-thermal, often invisible effects of electromagnetic fields that contribute to biological stress, environmental degradation, and a decline in the health integrity of exposed organisms. John Coates coined the term entropic waste to describe the harmful effects of RFR, highlighting the unnatural interference and energy dispersal in ecosystems and human health caused by pervasive wireless technologies. The mechanism of habituation. Habituation is often conceptualized as a type of attentional filter, where organisms amplify important signals and diminish their response to non-important ones. According to the probabilistic model developed by Samuel J. Gershman, organisms represent their state uncertainty as a probability distribution, updated according to Bayes' rule. This model uses Bayesian inference to track the posterior probability of a hidden state over time and maps this distribution to a response by computing the probability that the state exceeds a threshold. The model captures several key features of habituation. Simple habituation, repeated application of a stimulus, results in a progressive decrease in response. Spontaneous recovery. If the stimulus is withheld after response decrement, the response recovers over time. Potentiation. After multiple series of stimulus repetitions and spontaneous recoveries, the response decrement becomes more rapid or pronounced. Frequency and intensity sensitivity. Higher frequency and less intense stimuli result in faster and more pronounced response decrement. Impact of entropic waste on habituation. Entropic waste, primarily in the form of RFR, disrupts the natural probabilistic states and Bayesian inference processes in biological systems. This disruption creates inconsistencies and biological dissonances that interfere with effective learning and adaptation. Here's how entropic waste affects habituation. Shuffling probability states, RFR exposure can alter the sensory inputs received by organisms, leading to a constant fluctuation in the perceived intensity and frequency of stimuli. This shuffling of probability states creates a chaotic environment where organisms cannot accurately assess the threat or salience of stimuli. The Bayesian inference model relies on consistent and predictable inputs to update probability distributions and make accurate predictions. Entropic waste introduces noise and variability, undermining the model's ability to filter out non-threatening stimuli and focus on important signals. Biological dissonances. The inconsistencies caused by entropic waste lead to biological dissonances, where the organism's internal state does not align with the external environment. This misalignment disrupts the natural process of habituation, resulting in either exaggerated responses to benign stimuli or insufficient responses to actual threats. The organism's nervous system becomes overwhelmed by the constant barrage of RFR-induced noise, leading to heightened stress levels and impaired cognitive functions. This stress further exacerbates the disruption of habituation, making it difficult for organisms to adapt and learn effectively. Impacts on Bayesian inference. The model of Bayes' optimal filtering assumes that the sensory signals collected over time are accurate representations of the environment. However, RFR exposure can distort these signals, leading to incorrect updates in the probability distributions. The interference from entropic waste causes the posterior variance to remain high, preventing the organism from reaching a stable state of habituation. This prolonged uncertainty hampers the organism's ability to reduce its response to repetitive stimuli, leading to chronic stress and maladaptive behaviors. The broader implications. The interference of entropic waste with habituation has far-reaching implications for both individual organisms and ecosystems. The biological stress and cognitive impairments caused by RFR exposure can lead to a decline in overall health and well-being. Moreover, the disruption of natural learning processes can affect the survival and adaptability of species, contributing to ecological imbalances. Reinstating research and updating regulations. To mitigate the impact of entropic waste, it is imperative to support and fund research into the effects of RFR on biological systems. Regulatory bodies, such as the FCC, must update their guidelines in line with the latest scientific findings to protect public health and restore consumer confidence. By addressing the unnatural interference caused by entropic waste, we can ensure that organisms can habituate and learn effectively, maintaining the integrity of both health and ecosystems. Conclusion: entropic waste in the form of RFR disrupts the fundamental process of habituation across living organisms. By shuffling probability states and creating biological dissonances, it impairs Bayesian inference and the ability of biological systems to process and learn effectively. Understanding and addressing the impact of entropic waste is crucial for preserving the health and adaptability of organisms and ecosystems in an increasingly wireless world.